Today's lesson moves us into our geometry syllabus. We started by looking at geometric constructions, basic constructions, and I would have said to you that those constructions will be used as we continue to work. So you needed to make sure that you understood those constructions so that we could apply them when we started to do other work. Now we're looking at the topic of geometry, and geometry is basically solving problems by drawing. So you're given a body of information, and the solution that you will represent based on that information will be a drawing, and that drawing will reflect the information that you were given, the written information that you were given. Now, today we are focused on triangles, and a triangle is defined as a plane figure bounded by three straight sides. What that means is that it's a closed figure and it's bounded by three sides. Now, the interior angles, the angles on the inside of the triangle, those inside corners, will add up to 180 degrees, no matter what. Once you have a triangle, the interior angles, when you total them, will add up to 180 degrees. There are four types of triangles that we will concern ourselves with. The first construction is an equilateral triangle, and this is a plane figure with all sides equal and therefore all angles equal. The second triangle is a scalene triangle. This is a triangle with none of the sides measuring the same and therefore none of the angles measuring the same. The third triangle is a right angled triangle, and this basically is self-explanatory. One of the angles in this triangle will measure 90 degrees. In a right angled triangle as well, there is a line opposite to that 90-degree angle, and that line is referred to as the hypotenuse. You will have to make sure that you are clear on how to spell hypotenuse as well. And the last triangle for us is an isosceles triangle. An isosceles triangle is basically made up of two right angled triangles. So an isosceles will have two sides that measure the same and also two angles that measure the same. So with that information, we can now start to move into our constructions. Now, as usual, you will see the construction. I will try to focus on that construction only, and we will also turn off some of the lines so that you can focus on what is happening with your particular construction. So right now I'm taking those lines away so that we can begin to focus on construction number one. And construction number one is for a triangle given the length of a side or all three sides. And this triangle will always be an equilateral triangle. Now, to get that equilateral triangle, what you will do first is on your drawing paper, you will draw a line equal to the length of the side that you're given. So that's what's represented here right now. The next thing that you will do is that you will go to the end of the line, open compass to the length of the line, and scribe an arc. You will go to the other end of the line, do the same thing, scribe another arc, and these arcs will intersect. So if I show you those arcs in now, then the construction starts to look something like this, with those arcs pulled in. Now you're concerned then with the intersection at the top for those arcs. If you draw lines from that point of intersection to the end of the line here and to the end of the line here, what you would have produced is an equilateral triangle. So this basically is what your finished construction would look like. Relatively simple, no problems at all. So we can now move to construction number two. In construction number 2, requires us to produce a triangle. This will be a scaling triangle given the length of three sides, all three sides. So let's say that our sides measured 70 millimeters, 60 millimeters, and 55 millimeters. Let's just say that. We call some numbers. I'll again take off those lines for you so that you don't have to worry. So let me just take out some of what is there. And then we can proceed to do the construction. So you started now with the length of a line. In this case, let's say that that length is 70 millimeters. So we have 70 millimeters marked on the page. You will then take your compass and open it to the length of the second side, which is 60. So compass open to 60. You go to one end of the line and you scribe a curve at the top. You open compass to the other length, which in this case is 55, and you go to the opposite end and you scribe a curve to intersect that first curve. So once you have scribed those curves, your construction now starts to look something like this. So this curve would represent the curve that you scribed at 60, and this one would represent the curve that you scribed at 55. So to complete the construction, just like you did on the first one, all you will do is connect the point of intersection to the ends of your first line, and that should produce your triangle. So this then is your scaling triangle given the length of all three sides, represented in blue here. So we can quickly move on to the next construction. This is to construct a triangle given the length of two sides and one angle. So we're bringing back the constructions, the basic constructions that we started to do. Given the length of two sides and one angle. So again, we get rid of some stuff just to make things clearer. So you start the construction with this line. This line is equal to the length of your first side. So let's say that our sides measured 70 millimeters, 60 millimeters, and the angle that we want measures 30 degrees. You start with a line 70 millimeters long. No problem. Your next job is to construct the angle that you're given. So to construct that angle, we know that we would start with this arc. Compass open to a convenient radius and you scribe the arc, and then you go to where that arc cuts the line and you scribe this arc, and that would give you a 60-degree angle. But you know that you want to get a 30-degree angle, so to get 30 degrees you're gonna have to bisect. So in this case, to bisect now, what you'd be doing here is scribing an arc on the inside like this, and then you would proceed to draw in that bisector and extend that bisector. So that bisector is fairly long. And then on that bisector, you will mark off the length of the second side. Now remember, the length of the second side is 60. So you will measure from here, somewhere up here, mark off 60 millimeters. And at that point then, where the 60 millimeters is marked off, once you connect that to the end of the line, then you would have completed a triangle with the information that you were given. Two sides measuring 70 and 60 millimeters, and one angle measuring 30 degrees. Again, relatively simple construction. Let's move to construction number 4. So we're moving all around the place on this one. Make it a little smaller so that you can see everything. And then just let me quickly take out a couple of the lines so that we are all at the same place. So what we have here on this drawing now is a line, and this line is equal to the hypotenuse of a triangle. So to do this construction, you have to be given the hypotenuse and you have to be given one angle. In this case, that angle is 60 degrees. So let's say that the hypotenuse were given as 70 millimeters, and then the angle were given to you as 60 degrees. You would start with a line equal to the length of the hypotenuse. You would bisect that line, that is represented here. We should all know how to bisect a line. And you will draw in that bisector. So that bisector now gives you a midpoint that can be used to draw a semicircle on this line. So if we put in that semicircle now, put in that semicircle for you, then you see this curve represented on the page. At one end of the line now, you want to construct the angle that you're given. So it's a 60-degree angle. We know to construct a 60-degree angle. So you construct that 60-degree angle and you scribe your arcs, make your cut, and once you have constructed that 60-degree angle, you draw it in and you extend that line to cut the circumference of the curve. So this point is what's important for you. This goes to cut the curve, and where it cuts the curve, you will then connect that to the other end of the line, and you would have actually produced a right angle triangle. So if we put in the outline now, you will see the construction being completed. This angle here is 90 degrees. This is the hypotenuse, which is always opposite to the 90-degree angle. So this provides the information that you were given in the solution, which basically is a triangle. The next construction for you, it's a little bit more confusing, I guess, if you want to put it like that. But once we're following the steps in a systematic way, we will not really have any problems. This is to produce a triangle when you are given the perimeter. You know, the perimeter is the distance all around the shape. So let's say we were given a perimeter of 140, and then we were also given the height of the triangle. The height is how tall the triangle is. So let's say that we were given a height of 30 millimeters. Now, to produce this triangle, what you would do, first let me take off all of the extras. Okay, so we've made all those lines that we don't want disappear. So first thing that you would do is draw a line equal to half the perimeter. So if the perimeter is 140, then this horizontal line is 70 millimeters long. And at one end of the line, you will produce a 90-degree angle. Produce basically for you is that you will construct 90 degrees, and you know how to do that. And then you will mark off the height of the triangle. So we've said the height is 30, so we mark off this height then as 30 millimeters. Once you have done that, then you will connect the point where you've marked off that 30 millimeters to the other end of the line. So this is what the construction will look like now. Now, you know how to bisect a line. So this line, this connecting line, we want to bisect that line, find the midpoint of that line. In order to do that, we know how that construction goes. We know how we will scribe the arcs, and then we know that we draw in that bisector. And that bisector, cutting the purple line that you can see on your page, will extend down and also cut the horizontal line. And it's the point where it cuts the horizontal line down here that's important for you. Where it cuts that horizontal line, you will join these 2 points. From the height of the triangle that you marked off, you will join to that point of intersection with the bisector. So I'll make that an outline now, because that is one of the sides of your triangle. And if you look carefully, you will see that I have marked here a right angle triangle, because this construction actually will give you an isosceles triangle, which is 2 right angle triangles placed together. So to get the next half of the triangle, all you will need to do is flip this over to the other side. So to flip, what we will do is we'll put the compass point here that I'm highlighting, open to where the bisector cuts, and swing a curve around to the other side. That basically allows us to transfer the length around to the other side. And once we have done that, then we can put in the other two lines, and that will allow us to have the completed triangle. If you're following these steps, make sure that you follow them slowly, one step at a time, just to make sure that everything settles, because I know that it is a few steps and you have to be very careful with regards following them. Now the last construction for us is to produce a triangle given the perimeter and the ratio of sides. So in this instance, let's say again that the perimeter were 140 millimeters and the ratio of sides was 2 to 3 to 6. What we're doing is that we're going to put down that perimeter on a straight line. So this line, horizontal construction line that we have running across here, will actually be the perimeter of the triangle that we want to construct. I'm just taking out a couple of those lines for you again. So this line across here is equal to the length of the perimeter. And since we have a ratio of 2 to 3 to 6, when we total 6 and 3 is 9, 9 and 2 is 11, then we can proceed to, like, we're dividing that line into 11 equal parts, and you know those steps, so you should be able to follow those steps as well. And since we want the ratio, you know how to mark off the ratio in this instance. So we will mark off our ratio now to show the divisions at 2, at 3, and at 6. So what we've really done is that we've taken that perimeter and put the 3 sides on that perimeter. So one side should measure this distance here, the next side should measure this distance here, and the third side should measure this distance here. That's the ratio that we were asked to produce. So for us then, we will go to the point of intersection at 2, open to the end of the line here, and we will scribe a curve coming up like so. Then we will go to the point of intersection at 3, open to the other end of the line, and scribe another curve to come up and intersect as well. So if I drop those curves in for you now, you will see that the construction looks something like this. So in this case, these two curves represent the intersection of the curves that I would have told you that we're joining, and then all we do is connect to the ratio lines and we would have completed the construction as stated. So this side here would be equal to this distance here, this side here would be equal to this distance here, and obviously the one at the bottom would stay as is. So this perimeter would be equal to the distance 140 millimeters as was drawn initially. This is our first look at triangles. I'm asking you to please practice these constructions so that you are very familiar with them, so that if you have to do an assignment at any point in time, that you're able to complete it. And I'm also asking you to make sure that you know the definition for a triangle and that you know the definition for the different types of triangles: equilateral, scalene, right angle, and isosceles. I really enjoyed bringing these lessons to you, and I hope that there's clarity and that you're able to competently complete these constructions as we go on.